It is day 4 in geometry, and today is, let's see, it's Thursday, August, is it the 7th? Okay, I'm going to put that on here. Thursday, August 7th. Okay, and for your do now, I made a little worksheet for you. Just 2 questions. Obviously, there's a few parts within each question, but the first part here says to describe each type of angle below and then draw and label an example of each. So let's start with acute. Who can describe an acute angle to me? An angle less than 90 degrees. Perfect, perfect. So if you put a different definition, we'll want to correct that on your paper because this will be a great guide to look back at. An angle that is, I'm just going to write less than 90 degrees. And we'll go ahead and do the descriptions of each, and then I'll draw a picture. How would we describe a right angle? 90 degrees exactly. Perfect. So I'm going to write exactly 90 degrees. And last but not least, how do we describe an obtuse angle? More than 90 degrees. Perfect. More than 90 degrees. Now, I like to start with the right angle. That's kind of like our reference point because we're always talking about 90 degrees. So it's good to know exactly what that looks like. So we're going to start by drawing our little ray. Let me get my different color here. So I'm going to draw a straight line at the bottom here, like that. And we'll put an arrow on one end and a point on the other. And what's this called again? Just this. It's not an angle yet. You guys remember? A ray. Good. Ray has a start point and then the other end goes on forever. So if I wanted to draw a 90-degree angle, put my protractor here, what would I do to make sure I create a 90-degree angle? How could I do this? It's kind of hard to describe, isn't it? What should I do? Should I like make a mark here? Straight up. Okay, yeah, straight up from that point because here's 90. We want to line up the other ray with the measure that we're trying to make. So because it's 90, we're going to line it up with 90. So I can make a little point right there. And I'm just going to line up my straight edge with what will become my vertex. And with that little point I made. There we go. So there's my 90-degree angle. And what am I missing on the inside of my angle? The box. Good. So that box tells us it's a perfect 90-degree angle. Beautiful. Okay. Acute angle, less than 90. So is that going to look smaller or bigger than a 90?
Smaller. I did a 30-degree angle.
A 30-degree angle. Good. So I'm going to start with my ray again. And I'll go with the number you said, 30. So let's put this here. Didn't really give you much space, so using the protractor is kind of tricky. That's a little bit on me. You can really tell on this one how these protractors are not super accurate. Because if I were to line up this all the way across, you'll notice, here, let me do this. Well, maybe it's not as easy to tell as I thought it would be. But if I take a straight line and I try to line up the circle with the other line here, you can notice there's a very slight tilt it's not perfect. So your angles are always going to be a tiny bit off, but that's fine. We just don't have perfect tools here. So anyways, I'm going to do 30. So I'm making a little mark at the 30, and we're going to connect these 2 points. Okay. Now you didn't have to do a 30-degree angle, but does everybody's acute angle look somewhat like this? Good deal. I see people shaking or nodding their heads. And then inside of our angle, instead of a box, what are we going to put? Yeah, like a little, an arc. That's okay. An arc. That's all right. That's about how I talk sometimes. Arc. That's what we do. Okay, so now an obtuse angle, this one's going to be a little trickier to draw, especially because I didn't give you a lot of space. So we can just estimate it. I'll start again with a ray. And instead of going straight up and down or tilted inward where it makes it smaller, now we need to tilt it outward to make our angle more than 90 degrees. So I'm just going to pick a random spot, draw my other ray, and my arc. Okay, so now you should have a nice guide to look back at when we need to classify angles. Does everybody have those for number 1? Perfect. So now let's look at number 2. We are looking at constructions. And in the past, when I've taught this class, I find constructions we usually end up spending a little bit of time on, depending on the class. Some of us, I've noticed, really struggle with constructions. They can be tricky. And I think a lot of that is our compasses. Especially if yours is loose, you should have a nice tight compass. It shouldn't be super easy to open and close. That way it holds your angle really nicely. So it says on number 2 that we are going to construct a perpendicular bisector and an angle bisector. So starting with the perpendicular bisector, how would I begin this? If I have a point end and a pencil end, where am I going to put the point end first? On one of the dots. Okay.
And then don't you want it slightly over the middle?
Yes. So that's the next part that's important. Making sure you have your compass opened wide enough. If I had it closed like this, I'm not going to be able to do anything. I need to open it more than half the length. This would be about the halfway point. I want to make it bigger than that. So I've got it here, and we are just going to make a great big arc. Like that. Okay, so I've got my first arc. What should I do next?
Go to the other dot, and you have to keep your compass the exact same.
Yes, so next dot. Now the very important part that you just said is your compass has to stay exactly the same open size. If I make it bigger here and then I try to cross it, these intersections I'm going to create are not going to be in the middle of the line. So if you accidentally open it up too big or too small, you can remeasure and get that opening again. Just put your point back on that dot and close your compass until it is touching the first arc you made. And that's going to get you pretty close to where you need to be. Okay, so I'm going to go to the other point, and we're going to make another arc, just like that. Okay.
And you dot it where it intersects.
Aha, yes. So now we have 2 intersections, and we are going to mark those intersections as points. And what will I do with these points?
I'm not part of it. I got so far.
That's okay. So what we're trying to draw is a perpendicular bisector. Perpendicular Did we talk about what perpendicular means yesterday? Yes, no, maybe so. Does anybody know what perpendicular means?
Oh, you draw a line in the middle.
Yes, yes, we're going to be drawing a line in the middle. Perpendicular basically means that you have two lines crossing and it forms 90-degree angles, right angles all around. So what we just did here is we created points that we can draw our perpendicular bisector through. So we need to now take a straight edge and go through those points, trace a line, and we have a perpendicular bisector. Now there's a couple things that we need to label to show that it is in fact a perpendicular bisector. The first thing we need to do is show that this is 90 degrees. So how could I show that I've created a 90-degree angle? The square, good. So the square, I'm going to do that in red just to point out how important that is. You've got to show the square or I don't know it's perpendicular. Okay, so we've got that. And I don't know if it showed it in the video or not yesterday. This covers the perpendicular part. Did we talk about what bisect means? Anybody know what that means, or is it in your notes?
I don't know what they're called. They're two little lines on the
The two lines,
Yeah.
what about them?
I don't know. I have it on my notes. I don't know what they are.
That's okay. If anybody can find that in their notes, tell me, what does bisector mean? Or did I not teach you in that video?
I went to the bathroom at some point.
That's okay. That's okay. I'll tell you. So, bi, means two. Sector is like sections. You're creating two sections, and those two sections are equal to each other. So, to show that these two parts are now equal, they're split perfectly in half, we use tick marks. These are called tick marks. In geometry, whenever you see a tick mark on the same spot somewhere, it just means that they are the same or they are congruent. Okay. So your perpendicular bisector needs to have a box and it needs to have the tick marks. Once you've got those, you're good to go. Any questions about this one? Okay. So now let's look at the angle bisector then. And this one is the trickier of the two. So I'm going to walk us through this one and even give us a little guide. So there's basically 3 steps here. Step 1, where should I put my point to start? Yes, the vertex. So this little point right here where the angle creates a V, the vertex, that's where you should start the point of your compass, right on that vertex. And our compass needs to be open, not too big on this one. This time you don't want it to be open huge, because if we make it too big, then we are going to end up making our bisector go way off the page and we're going to run out of room. So let's make sure our compasses are open a little less than half the length of one of the rays making up our angle. And once you've got that open to this size-ish, we're going to create an arc. We want to make sure that the arc passes through both of the rays. Okay. Good. I see you guys making those arcs. Okay. So once we have that first arc, step 1 is complete. Does anybody remember what we do next? Yes.
Just wanted to ask a question. It already has an arc on the paper.
Ah, good.
Just use that.
Good observation. It already has an arc on the paper. So this can definitely be a little bit confusing, or not confusing, it could throw you off because you could think, oh, well, maybe I could use this arc as a starting point. If you look really, really, really closely, you might notice that it's not a perfect arc. It looks like it may have just been kind of drawn on. And so it's always a good idea, just to be safe, to go ahead and draw your own arc on there, because we don't want to start with a measurement that we don't know 100% if it's precise or not. You could test it. I could put my point here.
I mean, I drew the arc myself, but I actually did use the points of the already there arc, and I still got it.
Okay, well, you know, it might work. Let's see. I'm going to point my thing here, make my pencil touch this arc that already exists, and let's see if it's accurate. Okay. Not perfectly, but it almost looks like the edge of the arc is the same distance away from the one we just drew. There might be an arc that exists, if I open it even smaller, that will pass through those points. So this probably is one where you can use those edges there. So let's see. I'll make an even smaller one. Ah, okay. So look at this. Even though the edge is kind of bowing, you see that? I'll zoom in even more, if possible. Let me kind of focus this. Okay. Notice how this little intersection here and that little intersection there are on the same arc, and they are passing pretty closely through that original arc that was already on the worksheet. So technically, yes, it will work with this one, because we're just looking at where the arc crosses that line there. So it's okay if it doesn't match perfectly in the middle. We're just looking at those intersections, right? So we totally can use that. So once we have an arc and we decide which one we're going to use, you can use any of them. What is our next step? Where do I put the point of my compass next? Am I done using the vertex? Does anybody know?
Don't you put the point on where the arc starts to intersect the two rays?
Yes, perfect. Yes, yes, yes. So we just created an arc, and that arc gave us two intersections. So I'm going to mark, there's an intersection here, there's an intersection here. Those intersections are going to be our next points to use. So I'm going to take my compass and put the point on this intersection, and we're going to create two new arcs. Now I'm going to close my compass just a little bit so that these arcs will be inside the angle. That's what we want. So I'm going to do an arc here. And when I use the next intersection, should my compass change at all? No, no. We want to keep it consistent so that our measurements are accurate. So I'm going to put the point on the other intersection, and looky there. We've made a third intersection. So we're always creating new intersections. Those intersections become our start point for the next step. So I'm going to mark that one here. And we just have one more step to create this angle bisector. This is where we start using our vertex again. and we're gonna need a straight edge. Very similar to the finishing step of our perpendicular bisector. I want to line up with that intersection here with the vertex, and we'll just trace along there. And now we have an angle perfectly split in half. All right. Does everybody have that? Wonderful. Wonderful. Okay. Now, the angle bisector definitely has a few more steps. So, today what I would like for us to do, now that we have a little bit of practice, we're going to create a guide. And here's what this guide is going to look like. I've got one already made here. We're just going to use the back side of this paper. It'll say Angle Bisector Guide. We're going to label our steps, and we're going to write out some steps, because this is going to help you when we go back and have to do it on our own. You'll be able to see exactly, what do I do first? What do I do second? What do I do last? So, I'm going to have you flip your papers over, and let's begin making that guide together. So whatever I write, you write, and as we go, if we need to stop for just a moment, if I'm going a little too quick, tell me that. Just raise your hand, stop me, or shout out at me. All right, so we're going to write angle bisector guide. Okay. And that way you can keep this paper in your notes. You can always go back to it. And the first thing, once you've got that title, we're going to do is we're going to start by drawing a picture. We'll begin with a ray. One end has a point, one end has the arrow. Wonderful. Okay, and once you've got that ray, let's make an obtuse angle. So, is an obtuse angle more than 90 or less than 90? More than 90, good. So, instead of straight up and down, let's tilt it outside a little more. And we'll draw another ray coming off of that same point. So, here's our angle to begin with. Once you've got that angle, below, we're going to use some colors here. So if you want to follow along and use colors, the first color I'm going to use is red. And I'm going to circle my vertex. And beside my vertex, I'm going to write step 1. And below, we're going to write an explanation for step 1. Okay. So, step 1, we are going to place the point of the compass on the vertex. And we're going to create an arc. Now you can also make a note that says compass opening should be less than half of the side. So in the perpendicular bisector, we wanted it to be open more than half. This time, we're going to try to make it a little bit less than half. We want a smaller arc. So, compass should be open less than half the length of, let's see, less than half the length of one of the rays. The rays of the angle. I'll zoom in so you guys can see that a little better. Place the point of the compass on the vertex and create an arc. And so now I'll leave the words up, but we'll go ahead and do that. I'm going to put the point of the compass on the vertex right here. And I have my compass open less than half the length of the ray. And we will create our arc. Let's see. Okay. Here we go. And if it helps, I know for me, I like colors. I'm going to trace over this arc with red so that I know it's part of step 1. There we go. And then I'll pause and let everybody get caught up to there. And we'll go to step 2. All right, are we ready for step 2? Okay. So step 2, I'm going to switch to blue now. And what we're going to do in step 2 is now we're going to circle the new points, the new intersections. So we've created 2 intersections in step 1. There's one here, and there's one here. And I'm going to point to these. These are both step 2. Because it does not matter what order you do them in. You can do either one. Okay. So I'm going to write step 2. And at the end of class, if anybody wants a copy of this, you just let me know. I know sometimes when I'm taking notes, it doesn't come out as pretty as I'd like it to because you don't always know what's coming next. And obviously I've written this before, so if you want a nice, neat, color-coded version, you just let me know and I can make you a copy. So for step 2, we are now going to place the point of the compass on the intersections that we made in step 1. So place the point of the compass on the intersections created in step 1. Then we're going to create 2 new arcs. Now, for the size that your compass should be open in step 2, I used to teach that you should keep it the same size as step 1. However, I found after a few different tries in past classes that you actually can open it bigger if you want. And you can even maybe open it a little smaller. Well, no, I think it needs to actually be at least the same size or bigger, because we want to make sure that it crosses through the middle. So I'm going to say compass should be at least the same size as step 1. It can be opened bigger. And I'll make a note of that. Compass should be open at least as wide as in step 1. It can be bigger though. Okay, so there's that. Okay, so I'm going to demonstrate step 2 now, and if you're not done writing, I'm going to come right back to this. So let me just scooch it up for just a moment. So I'm going to take my compass, make sure that it's open as at least this big, but I'm going to go just a little bigger just for fun. And it should go on this point here. And we want to create 2 arcs inside of the angle. So here is 1 arc, and keep it the same for the other one. Here is 1 more arc. There we go. And I'm going to color those blue as well, so I know that that's what we did in step 2. Okay. And your arcs can be as long or as short as you want. The most important thing is that you make an X in the middle. You have to have that cross section, that intersection. Same with in step 1. If you wanted to, you could even just make 2 little marks on the rays. You don't have to make an arc all the way across. The most important part is those intersections. Okay, so that's step 2, and let me come back down to the words. And I'll pause for a moment. See lots of us writing. All right, so now I am going to start step 3. So I did red, blue, what color should we do next? Purple? Okay, let's do purple. Okay, so step 3, if you can guess, first we start at where 2 lines are meeting, then we start at another 2 lines meeting. We're going to start again where 2 lines are meeting. We're always starting at some sort of intersection every time. So step 3 is going to be going through right here. Now, I hope that purple is easy to tell apart from the blue. I know it's a little close. And I'm going to write out directions for step 3, and then we're done. Yes, we will make a line, absolutely. So for step 3, we are now going to connect the vertex from step 1 to the intersection we created in step 2. So let me write that. Using a straight edge. And I know it might be tempting to just freehand draw it, but in geometry you've got to be as precise as possible. Use a straight edge. So using a straight edge, draw a line from the vertex and I'm going to underline vertex in red so that it stands out. So from the vertex to the intersection created in step 2. Okay, so I'll leave that up in case anybody is still writing. And very slowly I'm going to move my page down and I'm going to trace that. I'm going to take a straight edge, start at the vertex, go through the intersection like that. And you can draw an arrow on the end if you want, but if you don't, it won't be counted wrong. But now we have an angle bisector, and if we did it right, our angle should be perfectly split in 2. It probably looks a little off to me because I made this line longer, but that shouldn't affect anything. I believe they're the same size. And we can even check. I'll check with our compass, or protractor. I mix those up sometimes. So let's see, I line this up and it looks like, let me get this where there's not a glare. Okay, if you had to guess about how many degrees my angle is that I've drawn, how many degrees does this look like, my whole angle? Does it look more like it's closer to 120 degrees or it's closer to 110 degrees? 110, it does. So I would say that's probably like 113, 114. So
It's exactly 114.
I bet you're right. Let's see. Let me just do this. Oh, hello. Yeah, right on 114. So if this whole angle is 114 degrees, and you don't have to write this part, this is a side note, 114 degrees, then if it's a bisector, it's cutting it in half. So how big should each of the smaller angles be now, since we cut it in half? How would I figure that out? If an angle bisector cuts an angle in half, I don't know off the top of my head. How would you find that number though? You know? I can tell you guys. Does anybody know, or are we just nervous to talk? Yes, divide it by 2. Because what we're doing here, no trick question. We have a big 114 degree angle. An angle bisector cuts the angle in half. So it will also cut the measure of the angle in half. So each of these smaller angles should be half of 114, which, let me see what that would be. 2 goes into 11. 5 times to make 10, 1, 4, 7 to make 14. Okay, so each of these angles should be about 57 degrees, and I can check it here. Let's see. Now I'm going to measure to the purple line. And look at that. It's almost perfectly at 57 degrees. So we did it right. Hey, that's okay. That's okay. I bet you were thinking because like 7 plus 7 is 14. So, oh, 70 plus 70, probably 114. Although it would actually be 140. Very, very close though. It's okay. I understand your reasoning. Okay. So here is our guide, our completed guide. Do any of you need to still see some of the words from step 3? Or do we have it all copied? We good? Beautiful. Okay. So I'm going to go ahead and pause this. And let's see. So we are back from our break. And I'm just going to title Geometry. We're still in Unit 1. And again, take great notes, and that way you have good references to look back on. Because just a reminder, whenever we do get to taking our quizzes, it's all open note. So if you have things written down, you can use that on the quiz. And I will never put something on a quiz that I have not explicitly shown to you. So if you write what I write, you'll do great. All right, so today is day 4, so I will title this as our day 4 notes.
How many days do you have left?
We have, let's see, I can look at this calendar. So we technically have 31 days, but the last week is day 28, 29, 30, 31, and that's finals week. I do not teach you during finals week. I usually let your final be available on that Monday or Tuesday after we do a little review. And then you can either take the final that day and be done, or some students like to study a few days and take it on the last day. But whenever we get closer to that time, I'll kind of explain how we structure that week. But finals week is usually my favorite week, because if you take the final on Monday, get your grade back the next day, hopefully, you've got the rest of the week to make corrections. So I still let you correct your final. So day 4 notes, and again, it is Thursday, August 7th. And we have been talking about angles, lines, rays. Yesterday we did complementary angles and supplementary angles. But now we are going to look at a few more relationships of angles. So, to begin these notes, I would like all of you to draw 2 lines going straight across the page. And I want those lines to be going at the exact same angle. Don't let them cross. I think one of the best ways to do it is just follow the blue lines on your notebook paper. That way you know that it's going to be nice and even. So here's one line, and then I'm going to skip 1, 2, 3, 4 maybe, and put another line a little lower down here, just like this. So once you have your 2 lines drawn, on each line, we're going to draw a symbol. And this symbol is going to look kind of like the arrows, also kind of like a play button. It's almost like you're going to draw a little triangle on the edge here. You can draw one of them. You could, sometimes people like to do 2. Just 1 is fine, but I'm going to do 2, just, I don't know, just because I feel like it. Okay. Have any of you ever seen something that looks like this? in a math class in the past.
It's like right in the back of my subconscious.
Yeah, it's back there somewhere. These lines are very special because they will never cross, ever. Parallel, yes, these are called parallel lines. So I want to write over to the side parallel, P-A-R-A-L-L-E-L, parallel lines. And they never cross, they're going at the same angle. And this is the symbol to show they are parallel. Parallel lines will always have these little triangles or little extra arrows on either of them. Now going through these parallel lines, we're going to draw a third line. And I'm going to make it kind of tilted like this. And we want that line to cross through both parallel lines, just like this. Now this third line also has a special name. This is called a transversal. So I'm going to write that word out here as well. T-R-A-N-S-V-E-R-S-A-L. Transversal. And a transversal is just a fancy word for a line that crosses through two other lines. Not something you necessarily have to know, but if you're curious, that's what it's called. Now you'll notice that this transversal going through the two parallel lines creates some angles. We're going to count those angles and we're going to label them. So I am going to start in pencil because I might have some edits to make and I want to be able to erase. We are going to label every single angle that has been created here. So let's start with this one. I have one angle here and we will call it A. And then we're going to go clockwise around. So the next angle to the right we'll call B. Now, angle A and angle B are not the same size. So, because they are not the same size, we don't want to give them the same amount of arcs. Because if I put one arc on angle A, if I put that same number of arcs, one arc, on another angle, that means that they are the same. So since they are not the same, we're going to do 2 arcs for angle B. The number of arcs will tell you which angles are equal. I know. I don't know what that banging is. I have no idea. Right. So we have angle A, angle B. Now we will go below and do angle C. Now, angle C, does it look like it might be the same size as any of the angles here? Might be hard to tell until we get them all labeled. I think you're right. Angle C and angle A are the same size. They have a special relationship that we'll talk about in a minute. So we're going to give angle C 1 arc as well. Just 1 arc. Okay. And we will call our last angle D. And how many arcs do you think D will get? 2. Good. 1, too. Okay, so as you can notice just from these 4 angles, when you have 2 lines crossing each other, when you've got a transversal, it creates 4 angles. I could add more transversals, it could create a million more angles, but in this scenario, we've got 4 angles. Anytime you have angles directly across from each other like this, like A and C or B and D, these are called vertical angles, and we're going to label that. Vertical angles are always equal anytime you have an angle across from each other. So I'm going to use colors now. I'm going to make A and C blue. And I'm going to point there and say vertical, V-E-R-T-I-C-A-L. Vertical angles are equal. And then I'll use, I don't know, I'll use pink for the other ones. D and B are vertical angles as well because they are right across from each other. So they're equal. Okay. Let me get a good eraser here, see if I can get some of these pencil marks out of the way. Vertical angles are equal. So we have 4 angles labeled. A and C are equal. D and B are equal. Now we're going to show 4 more angles down here. And here's where the relationships get really interesting. So we have A, B, C, D. Now we'll start over here with E. How many arcs do you think E will get? 1. 1 arc. Angle E is being created the same way as A. Notice these lines are parallel, which means they're going at the same angle. This transversal is the same line crossing through both parallel lines. So they are creating the same angle. Angle A and angle E are also equal. So we'll call that E. The next one will be F. And I think you're going to start to follow along. This is 2 arcs as well. Then G, 1 arc. And then H, 2 arcs. Okay. So, angles that are across from each other are equal, and angles that are in the same position, even if they're in different spots. Notice how angle A is the first one in this group of 4. Angle E is the first one in this group of 4. They're in the same position, just shifted down. Now, something that might make this a little easier to see, let me pause this. I want to grab something. All right, so that created a terrible glare, but I'm going to trace over this clear page just to prove that it works. Let me find a Sharpie. Okay. So I'm going to trace over angle A. I'm going to do these here and draw that. Draw that. Here is my angle A. So I'm going to take angle A and just shift it down. Ah, look at this. Oh, come on. It's the same. I could also flip it around and we'll see. This is the same. This is the same. I think that's kind of cool. I don't know. I'm also a little bit of a nerd. You have to be if you're going to be a math teacher. So let's write out the names of those relationships we just talked about. These are vertical angles if they're across from each other. The other relationship we talked about was the ones like D and H. These are called corresponding angles. corresponding. Corresponding angles are also equal. And we could do the same thing with the little angles. Like, here's B. You can notice that B and D are across from each other, and B and D are the same size. B and F are in the same position, and so they're the same size. They're corresponding. Okay, so there's ways that we can use this information, and I'm about to show you. So I'm going to shift this down just a little bit, and I'm going to draw that shape like this one more time, but a little smaller, maybe not as perfectly. Let me get my ruler. All right, so I am going to draw two more parallel lines, and I'm just going to use the ruler thickness as my guide. So I'll have my first line on top of the ruler, my next line on the bottom of the ruler, just like that. And I'm going to draw a transversal going through both lines. And let me see about how many degrees this would be. Like 75. Okay, let's say, after I show that that is parallel, so you can do the parallel symbol. You can either do it by drawing the triangles, or you can just draw more little arrowheads, if that makes sense. This angle here is 70 degrees. We'll just say it's 70. It looks like 78. Guys, I'm sorry. 70 degrees. Now, with just this one angle measure, could I figure out the measure of every other angle in this picture? I'll call this A, that's B, C, D, E, F, G, H. B and D. What kind of angles are those? What relationship do they have? And we wrote it just above this. These two. They're right across from each other. Almost. What's the other one? Almost.
Corresponding?
Corresponding are the ones that are in the same position, but different group of 4. When the angles are right across from each other, like this, they're vertical angles. Vertical, that's the word I wanted. That's okay. So we have 70 degrees right here. We'll call that angle B. Angle B is vertical to angle D. So they're equal. So what is the measure of angle D? 70. 70 degrees. Good. Okay, so I'm going to go ahead and write that in. I know that this is 70. So I've got 2 of my angles solved. Here, I'm going to actually write out a list. I need to solve angle A. I already have B. Oh wow, I shouldn't have done it like that. This is why I should use pencil, you guys. My notes are looking funky. Angle A, angle B, angle C, angle D, angle E, angle F, angle G, angle H. Okay, we know angle B is 70. Angle D is across from it, so it's also 70. Angle D, 70. Okay. With this information, can we know the measure of any other angles? Yes, yes, exactly. And these are the word that we've all been saying, corresponding, because they're in the same positions. D corresponds to H, and B corresponds to F. So these are also 70. 70, 70. So let's put that in. F and H, 70. 70. Okay. So we have half of our angles found. I want you to think back now to yesterday's notes. Whenever we learned about complementary and supplementary angles, I want you to think specifically about supplementary. So if you don't remember off the top of your head, go ahead and flip back to your notes. Yes, supplementary angles add up to 180 degrees. Now, they make a straight line, yes. Do you see any angle pairs here that make a straight line? Which ones? Could you give me the letter names? There's a bunch of different ones that will make 180 that are supplementary. It's almost unlimited answers. E and F? E and F, yes. E and F would absolutely, yes. E and F make a straight line. Now, what do I mean by that? I'll show you. Here's angle E. Here's angle F. This is the straight line they're making. See that? They're opening up to create a straight line. So this whole angle that they make should add up to 180 degrees. So let's write a formula down here at the bottom, or not a formula, an equation. Angle E plus angle F equal 180 degrees. Now, I don't know angle E, but I do know angle F. So we can plug in the value of F, which is 70. So now I'm going to write E plus F is 70 equals 180 degrees. And now we have an equation with a variable we need to solve for.
So
E
E is 110.
is 110. Now how'd you find that? What'd you do?
Subtract 70 from both sides.
Yes, yes. We're going to solve for E. So we subtract 70 from both sides. Those 70s cancel, and we get E equals 110.
And if E equals 110, then E does too.
So E is 110. I'm going to write that in. And E is across from G. So G is also 110. So I'm going to write that over here. 110, 110. So A and C should also be 110. Good. And why are those also 110? Yes, exactly. These are parallel lines going through, there's a transversal going through them at the same angle. So all of these angles should be corresponding to all of those angles. They're going to be the same, exactly the same. And you notice here, this looks like a huge problem that you had to solve for all these angles, but you really just had to solve for one. All the other ones, it was just recognizing kind of the puzzle pieces of where are the angles the same. And you can always go back and look at this to help you decide, well, if they're across from each other, they're equal. If they're right next to each other, they add up to 180. Okay. So I'll leave that up for a moment. That was a lot of writing. Let's see a few of us still finishing that up. So let me pause for about 1 minute here. All right, so we've taken some notes. I'm going to put these to the side, and each of you should have this worksheet, Solving for X, Parallel Lines, and Transversals. Now, something that I find helpful when working with problems like these is using colors and labeling things. So, what I'm going to do first is I'm going to mark all the angles that are equal to each other in one color. So if I start with this one, I know the angle across from it is equal, so I will do that. Then I know if I move down to the next section, I started with the angle on the top left. So in this section of 4 angles, I'm going to also start with the one on the top left, the one that's labeled 8 plus 16x. And I'm going to label that in pink. The one across from that is equal. Okay. Starting here can help us think about how are these two angles related to each other. If you want, you could label the other ones that are equal. You don't have to, but you can. So, this pink angle and this blue angle, are they equal to each other, or do they add up to 180? They add to 180. They're equal if they're across from each other, or if they're in the same position, but these aren't. They're right next to each other. They make a straight line. So, if it helps, you could even draw that straight line. These add up to 180. So, here's what we're going to do. I know that the pink plus the blue equals 180. I'm using the colors instead of variables here. Now, if I want to write the equation to solve for x, all we need to do is replace pink and blue with the values they give us in the original picture here.
Oh, so it's the same as before, it'd be 8 plus 16x plus 8x plus 4 equals 180.
Yes, exactly. You got it. So we're going to replace pink with 8 plus 16x. 8 plus 16x. And we're going to replace blue with 8x plus 4. And we're going to bring down everything else. We brought down that plus sign, and we know we're going to bring down that it's equal to 180. Now, anytime we are writing out an equation like this, the very first thing we want to do after it's written out, always, 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 I'm going to write this on a note to the side, is we want to see if we can combine like terms. So, do we see any like terms that can be put together or combined? 16x and 8x, that should make 24x. And then 8 plus 4 is 12. Good. Yes. So let me get some colors and we'll do that. Okay, so 16x and 8x. We can add those together because they both have x, and that gives us 24x. And then you said the 8 and the 4. And that, when we add them together, gives us 12. Plus 12. Okay, so everybody see how we got those? Okay. So, if it helps, cross things out after you've combined them so that you don't accidentally bring them down and get confused. I used 8, I used 16, I used 8x, I used 4. Done with those, so I'm going to cross them off. Now I have 24x plus 12. What else do I need? Equals 180. Good. Yes, now I can subtract 12 from both sides. Switch to pencil here. Minus 12, minus 12. We'll draw our line. Cross the 12s out. And what happens next? 24x equals, you said 168? Okay, perfect. 168.
And then you divide 24 by 24 and 168 by 24.
Perfect. Divide by 24 on both sides.
Which gives you 7.
X equals 7. Good. Okay, so this might look like a lot of steps. It'll start to feel more natural the more of these we do. So we'll do a few more together like that. But as you guys are copying this down, and before we move on, does anyone have questions, or is anybody unsure or confused about any part of this process so far? Is it making sense? Okay. that over. Do we want to try number 2? Okay, so number 2. Now we have 2 other angles, x plus 109 and 100 degrees. So let's start by marking all of the angles that are equal to each other. X plus 109. And which angles would be equal? I know they're not labeled. Top left, good. So the one right across from it, the vertical angle, these will be equal. Any others? Yeah, the 100 is going to be equal, and the one across from that. So these are all equal to each other. So I'm going to be setting up my equation differently this time. In number 1, the angles that we were using to solve for x were right next to each other, and they created a straight line, so they added up to 180. Now in this case, these angles are equal to each other, so we're not going to add them together and set them equal to 180. This time, I'm going to write a note here. Set equal to each other. So in this case, I have, well, this one is 100, so I'm just going to go ahead and write 100. And it's equal to the other angle. That's pink. So I can replace my little pink dot with the values they give us for that angle. And that's going to be x plus 109. So let's write 100 equals x plus 109. Okay.
So subtract 109 from 100?
Yes. We want to get x by itself. That's our goal, is to solve for x. So to do that, we got to get rid of the plus 109, so we'll do minus 109 on both sides. Minus 109. We'll draw a line to separate the steps. And what do we do from here? Cancel out.
And then you're left with negative 9 equals x.
Perfect. Negative 9 equals x. Beautiful. There we go. That's number 2. X is negative 9. Very nice. Any questions on number 2? Okay, how about, can we go to number 3? I'm going to go ahead and shift it. Stop me if you need more time. Number 3. At first glance, do you think these angles are equal to each other, or do you think they add up to 180? What do we think? Or are we not sure? Should we do our color coding? see. Let's see. I'm gonna mark this one in pink. And what else? I know the one right across from it's equal, right? So let's mark that. Okay, so this one is the top right of these 4 angles. Now I'm gonna go to the bottom 4 angles. 100 is also the top right. So, you see that? So are these going to be equal or add up to 180? They're going to be equal. They're going to be equal. And this will get easier to identify the more practice we do. But for now, they are equal. So what equation would we write? Perfect. 11x plus 12 is equal to 100. 11x plus 12 equals 100. Okay, and what would I do from here? Now I have my equation set up. Subtract 12 from both sides. Good, 11x equals 88. Good, divide by 11. X equals 8. Perfect. Perfect, perfect. Okay. Now I am gonna have you guys see if you can try number 4. Okay. See if you can try number 4 either on your own or you're welcome to work with a classmate. If you feel like you're stuck, please come on up here and I'm happy to help. But I'll set a little timer, and when that timer's up, we'll go over it as a class. Let's see how well this is sticking. Let's try number 4 on your own or with a classmate. I'll pause that. All right, so number 4. Are these equal to each other or do they add up to 180? They're equal. How do we know they're equal?
Because they're not right beside each other on the line, so they're not 180.
Yes, they're not right next to each other, so they're not going to be 180. They are right across from each other, so they're vertical angles. Vertical angles. So they're equal. Okay, so what equation should we write to solve for x here? Yes, 110 equals 23x minus 5. Perfect. So we've got our equation set up. Where should we go from here? Add 5. Perfect. Add 5. And our 5s will cancel. 110 plus 5. 115 equals, I'll bring down 23x. And what's my last step? Very close. We don't want to subtract 23. Right here we have 23x, which means 23 times x. What's the opposite of times? Divide. Good. So we're going to divide by 23. on both sides. Okay, and those will cancel out. So 115 divided by 23, what does that give us? 5. Let me check. I didn't do this one yet. Oh, let me get a calculator. Okay. 115 divided by 23, it is 5. Okay, so, alright, so I'm going to write that now. 5 equals X. And that is our answer. Okay, any questions about this one? Alright, I'm just going to mark that here. Now, what I'm going to have us do before we wrap things up is I'd like to go through each question on this paper and see if we can recognize whether we would need to set them equal or whether we would add them to 180. And let's just mark each question so that you already know how to set it up. So, next page, number 5. Equal or 180? What do we think for number 5? Equal. These angles are corresponding. So for number 5, I'm going to write set equal. Number 6, you think these are equal or 180? I hear both answers. Well, I hear 180, I hear equal. Who can defend their answer? Equal? Why are they equal?
They're not equal because it's not vertical.
These two aren't vertical?
It's not right next to each other. I can't think of
Oh, yes. If they're not right next to each other, then they're not going to add up to 180. Since they are across from each other, they're vertical, which means they're equal. So set equal. Number 7, equal or 180? Equal again. These are corresponding. How about number 8? 180. This time they form a straight line. So I'm going to write add up to equal 180. Perfect. Okay, let's go through the rest of those real quick. Number 9. This one's a little funky. Equal. This one's tricky because it's not a perfect corresponding or a perfect vertical. You have to do some thinking here. These are equal, but these are equal. So these are also equal. Okay, so we will set these equal for number 9. How about 10? Equal again. Corresponding. How about 11? Equal again. How about 12? Let's see, are these angles the same size? It's hard to tell. Let me try this. Okay. If these are equal, then I should be able to move this onto the 80 and it should match, right? Oh. I don't think they're the same size, are they? One of those is an acute angle, and one of those is an obtuse. So here's something that can really help. If you notice, the angles that have less space between them, like when they're directly side by side, like these are, they almost always add up to 180. Like on number 8, they're right next to each other, 180. Number 12, they're right next to each other, 180. The other thing you can do is go through and mark all the angles that are equal. These across, these across. Notice how that 80 is not included, so they can't be equal. So these add up to equal 180. Yes. Alright, does that make sense to everybody? I know these can be tricky, and we'll do more practice on this next week. But I just want to give you guys a starting point. And then let's just mark the rest of these real quick. Next page, 13, equal or 180? What do we think? Mm-hmm. 180, perfect. Notice they make a straight line. They're also very clearly not the same size. One is really big, one is really small. So these are going to add up to equal 180. Number 14. Equal or 180? What do we think? Are we not sure? Equal. These are equal. See how the angles are all able to be the same color here? These are all equal. Okay, how about 15? Equal or 180? Let's check. This one's equal, this one's equal, this one's equal, this one's equal. Yep, you're right, these are equal. Okay, so set equal. How about 16? Are these equal to each other, or are they going to add up to 180? Equal. These are vertical angles. They're right across. When that's the case, we set them equal. Okay, 4 more. Then we'll be done. 17, equal or 180? $180. Good. The ones that are right next to each other, 180. So add up to equal 180. Okay. 18, equal or 180? Equal. Good. Vertical angles are equal. Equal. All right, number 19. Equal, good, and more vertical angles. Equal. And last but not least, number 20. Equal again. Good, good. Okay, so now we have all of those written out nicely, and I'm not going to have you do any more today. I've given you lots. My plan is next week we will do a little more practice with this, and we will start moving towards other things. This worksheet is yours. If you would like to do some more practice, you're absolutely welcome to work on this. However, you do not have to. It's optional. It's up to you. But that's going to be it today. Thursdays, I try not to give exit tickets to allow you to make corrections on the exit tickets from earlier in the week. I know we just had a note-taking exit ticket yesterday because I was not here, but we'll just call that a freebie for you guys. So, that is all. Remember, no class tomorrow because it's Friday. We don't have class on Fridays. If you feel a little bit unconfident about anything we've talked about this week, or you just want to make sure that you understand everything really nicely, feel free to come in tomorrow. I will be here from 9 until noon, 12, during office hours. All are welcome. So, I hope you all have a wonderful weekend. That's it.